Okay, I think we're good. Yeah, thank you. All right. So now I think we're rocking and rolling. You got your written assignment 1 in, you've got your practice test, right? So I gave you a practice test. I'll do the exact same thing that we did for the last one, right? So you're gonna go through and you're gonna try all these problems. And then for completion marks at the beginning of class on Thursday, I'll go around and just make sure that you did something, right? Something reasonable. And you'll get 1 completion mark, which is going to count as an assignment. Okay, so these completion marks are easy assignment marks, right? So you'll want to get those done. Okay. Well, it doesn't have to be right. You just have to try it. Okay. Completion marks. It is completion marks for the practice test. Okay, so we've got our practice test. So do the practice test. Do practice test number 2 for class on Thursday. So not a lot of time, right? For 1 completion mark. Yeah. So I'm kind of worried because there's no echo, but I'm not on mute, so, but weird, right? Who knows? So, right, so that's, you're all gonna do the practice test, right? Attempt it. Okay. And show me all your work. Even if it's wrong, I don't care. As long as you've tried it, that's what's important. Okay. And then on Thursday, we'll go through the practice test together. Okay. And as review for the test, which is on Tuesday, yikes, came out of nowhere. So test number 2 is on Tuesday, November 6th. All right. So we'll do the review. We'll finish up chapter 5 today, do the review on Thursday, test on Tuesday. Yikes. Start chapter 6 on next Thursday. Thank you. Okay. So what I want you to do, right, written assignment 2 is due on Thursday as well, right? So what I want you to do is I want you to take pictures of it before you hand it in on Thursday, because what I'm going to do is I'm going to post the solutions, but I won't be able to return it to you before the test on Tuesday, right? So I'll post the solutions, you'll have the solutions, and I think it's good if you have a copy of your work, right? So you can check to make sure you are on the right track. Okay, so before handing in assignment 2 on Thursday, take pictures of it to study from. What you'll notice if you have a peek at the practice test, looking at some of these long answer questions, and those are the money makers, right? The long answer questions. These should look fairly familiar, right? If you look at your assignments, look at the practice tests, right? What you'll find is once you've done a lot of these questions, there's only so many different ways that I could ask a question, right? Find the unknown payment amounts, right? Find the value at some date, right? That kind of thing. So, any questions about all that stuff that's due and whatever? Right. So like I said, if you don't have written assignment 2 or the practice test, come grab it after class. Make sure you have it though. So let's do a little bit of review from last day. So we kept talking about compound interest, right? Where we use the formula, the future value is the present value times 1 plus I to the power of n. Where I'm not going to define the future value and the present value. I think we're okay with those, right? But where I is the periodic interest rate, and n, right, is the number of compoundings. Oh, and I'll put the formula on here. I, right, is R over F. Where F is the compounding frequency. And if you're working on assignment 2, or if you're working on the practice test, right, you'll notice that you want to have these compounding frequencies memorized, right? Some of these are easy, right? Weekly, 52, quarterly, 4, right? The only one that kind of sneaks by us is the bi-weekly, which is 26, right? But at the very beginning, the first page of chapter 5, there's a list of the ones that you should keep track of, right? So F is the compounding frequency and N is the number of compoundings. Where N we calculate as time times the frequency, right? And that's also on your formula sheet. Okay. So for test 2, right, just like we did, so written assignment 1 was on simple interest, written assignment 2 is on compound interest, or is on compound interest, right? Test 2 is going to be on both of them, right? Simple and compound. So the first thing that you want to do when you read a question is figure out, okay, do I have simple interest or do I have compound interest, right? Because that's going to dictate where on your formula sheet you have to be working, right? So last day, right, from this future value is the present value times 1 plus I to the power of n, right? We've solved for the future, but well, the future value is right there. We've solved for the present value, we solved for I, and we solved for n, and they're all given to you on your formula sheet, right? So you've seen how we solve for all of them, but they're all given to you on the formula sheet, right? So solving for R, if we have compound interest problems, right, we have to first find the periodic interest rate and then find R, right? So there's 2 steps solving for R, and we did examples of this last class, right? So first we have to solve for I, and then the second step is use I equals R over F to solve for R, right? So it becomes this 2-phase problem, which kind of makes sense, right? If we have a problem, we first have to take our R and convert it to I for compound interest. So finding R, we have to find I and then convert it to R. Same thing for solving for T. Your first step is going to be solving for N, right? The number of compoundings. Solve for N. We also said, we snuck a little step in there, and we said, well, we can't use a fraction of a compounding, right? So we always have to round up, regardless of if we have 10.3 compoundings, right? We have to have 11 compoundings, because rounding down to 10, we wouldn't have quite as much money as we thought we were gonna, right? And so that's why we always have to round up to the nearest whole compounding. So I'll call that kind of, actually I'll make a separate note here, because the second step is use n is time times the frequency to solve for t. Here I'll make that note. When solving for n, we always need to round up to the nearest whole value. To the nearest whole value. Okay. And we'll see a quick example of that again today, so just solidify it, right? But that's going to be important. Okay. And then we talked about the fun trick of finding the doubling time, right? The rule of 72. So we can always kind of approximate the doubling time by 72 over the rate as a percentage, right? So if I tell you, so if you go to the bank and they tell you, oh, you can deposit this amount of money and we'll give you a rate of 3%, right? So then quickly in your head or on your phone, you could do 72 divided by 3. And then you would have a quick gauge of how quickly your money would grow, right? Because it would take 24 years for any amount of money to double, right? So it doesn't matter how much you deposit, right? So that rule of 72 is just a quick check of how quickly does 3% work for me, right? 6%, 7%, that kind of thing. Right. So, we can approximate. Remember, it's just a quick approximation, right? But good enough. We can approximate the doubling time in years at any rate R% by using the rule of 72. Which says that the doubling time is roughly equal to 72 over R as a percentage. Right, so that's the important part, is that we keep R as the percentage. Okay. Which is kind of tricky because I've been you have to convert to a decimal, you have to convert to a decimal, and then here we don't convert to a decimal. Okay. So, but that's the, also I think, yeah, it makes a quick appearance on the short answer. Just a quick note about the short answer on the practice test, right? They're just to give you an idea of the length. There I can have any sort of short answer, right? So they're not necessarily just like this, right? But the long answer, you can expect to see questions kind of like that, right? So first one might be 2 different offers. You have to compare which one's better, right? But we'll go through that next day. I get carried away, practice test. Okay, so doubling time would be a quick short answer question. Okay. So, any questions before we start with today? No? Okay, so let's start with a little example, kind of a, hate to call it a warm-up example, but that's what it is. I gotta steal this, put it in here. So let's do example 187. Okay. I've decided to make annual contributions to a fund in order to have $10,000 in 3 years so that I can purchase a car. Okay, great. Each contribution will be of equal value, and the fund into which I'm contributing earns a rate of return of 4.4% compounded quarterly. How much must I contribute each year? Okay, and I'm going to add a little blurb here. If I start today. Okay. Because it's not clear if we're making a payment today or a year from now. So I'm just going to say we start today, then make a payment in a year, and then a year, and then a year, for 3 years. Okay? Just to clarify. So on the test, it should be very obvious when you're making payments and when you're not, but some of these examples are a little wishy-washy. Okay. On the test, right, we want to make sure, okay, do we have simple interest or compound interest, right? We know because here we're compounding, so we have compound interest, right? Which means you can basically just ignore the rest of the formula sheet, right, and just focus on your compound interest section. Okay. I managed to forget my formula sheet. I'll just wing it. Okay, thank you. They're all in here. I promise. But thank you. Okay, so first thing we're gonna do, right, is we're gonna make a timeline, map out all these things, figure out our plan of attack here, right? And so I'm gonna start with a line today and then 3 years from now. Today and then 1 year, 2 years. Because I'm making annual contributions, right? So I'm paying each year, 1 year, 2 years, and 3 years. So what I know, right, is that at the end of 3 years here, I want to have a total of $10,000, right? So whatever I got to pay to make that happen, that's what we have to figure out. So we've got these unknown payment amounts, right? And so I've decided to make, so each contribution will be of equal value, right? And so at each date, even though we don't know the value, right, that's what we're trying to find out, we're just going to denote it by X, right? Sound familiar from your assignments? Both of them? I know. Okay. So here we've got a payment of X, right? Because I added that, okay, if I start one payment today and then a payment a year from now, 2 years, and then at 3 years, right? And then I've got X here and X here and X here. Right? Because yeah.
Oh, okay.
Yeah. Okay. So then, okay. So now, right, we have to figure out what X is. Okay. On the assignments, I think it's been, you know, the second payment or the third payment is twice as large as the second, things like that, right? All you do is you put 2X, for example, right? Or 3X or 4X or whatever I tell you the amount is, right? But you're always going to reference to X, right? The single amount X. Okay? Here they're all equal, so they're all going to be X. Okay? So then what we're saying, if we're mapping this out, right? I don't even have to tell you the focal date because we need these amounts, right? All of these amounts to add up to 10,000, right? Because that's our savings goal. And so automatically, right, we're gonna have, this is our focal date at 3 years, right? That's the only one that makes sense. For compound interest, you can actually make your focal date any date and it'll still work out. But that means you would have to recalculate your 10,000 to some other amount, which doesn't really make sense. Right? More work. So the least amount of work is going to be to use 3 years as our focal date. You always want to try to pick one that has the least amount of work. And the only way that you're going to know which one has the least amount of work is by doing all these problems. And then you'll start to be able to anticipate, oh, then I have to calculate this with that. And I don't really want to do that. So I'll make that the focal date. That'll make sense in about a month from now. Trust me. So this one gets pulled forward to some future value 1. This little guy's going to get pulled forward to some future value 2. And this little guy's going to get pulled forward to some future value 3. And all together, they have to equal $10,000. Right? So what we're doing here, right? Future value 1 is going to be more than X. Future value 2 is more than future value 1. Future value 3 is more than future value 2, right? Because this X has been sitting in there earning 4.4% compounded quarterly for longer, right? This one sat in there for a little bit less time, and this one sat in there for even less time. This one sat in there for no time, right? And so that's why we've got different values here, but same values there, right? And that's kind of, we're going to get into kind of car payments and mortgage payments and all that kind of stuff, but that's how they all stay the same, right? Because you're paying it off and they all add up to different amounts in the end. And we'll get there, okay? But that's the same idea. So on each of these, you know what? I'm going to jot down what my R and my F are. Just kind of at the top somewhere, just because it's good to have them visible. So my R is 0.044. And my compounding frequency is quarterly, so 4. All of these have the same rate. And so I'm just going to calculate my I here. My I is R over F, which is 0.044 over 4. Take a stab at it, say it's 0.011. So now, the only thing that's missing for our timeline is the N on each of these arrows. Right? N is time times the frequency. So I'll start with this first one. N is time times the frequency, time in years, right? From today to 3 years from now is going to be 3 years. Right? 3 times the frequency, which is 4. So I have 12 compoundings in that time. Right? Then going on to the next one, I've got N is time times the frequency. The time between 1 year and 3 years, remember you're looking at the time, the length of the arrow, right? Between 1 year and 3 years is 2 years times 4, so I've got 8 compoundings. And then finally I've got time times the frequency is 1 year times 4, which is just 4 compoundings. And then that X at 3 years sits there for technically 0 compoundings, but we just ignore it, right? It's just X. So all of this is a complete timeline. So I want to see complete timelines. This has everything that I'm expecting to see. Right? And remember the assignments, I am going to mark your timelines especially hard, right? Because I want you to be really good at timelines for the test. Okay? So, because I know on assignments you have time to look at the notes, you have time to think about things, talk to your friends, figure it out. The test, not so much. Okay? So now we've got all the work. The hard part's over, right? Now we just have to calculate future value 1, 2, and 3. Tedious, but we can do it, right? So the future value 1 is the present value times 1 plus I to the power of n. Right? The present value, so the present value is always on the left-hand side, and the future value is always on the right-hand side of the arrow, right? And one quick check that you should be doing is that the present value always has to be less than the future value, right? Whether you put some amount into the bank, it's going to grow to a bigger amount, right? Put some amount in, it's going to grow to a bigger amount. Or even if you borrow some amount, you have to pay back a bigger amount just because you have to pay interest on it, right? So that's a quick check that you can do and say, okay, my present value has to be less than my future value, right? And for each of these, we've got a present value of x, right? And the I for all of these is the same. So the only thing that's going to change between these calculations is your n, right? We've got 4, 8, and 12. So for future value 1, the present value is x times 1 plus 0.011 to the power of 4. Make sure you pick the n that corresponds to the future value 1. So from here, I get 1.011 to the power of 4 is I'm going to move the x to the right-hand side, 1.04473139 times x. I already know that I need to use that 1.044 whatever later on in my calculations. So I'm just going to store this in 1, keep it for later, right? So I'll just make a little note here that I'm storing this in 1. Okay, so moving on. Future value 2, again, is the present value times 1 plus I to the power of n. Present value is x still, times 1 plus 0.011 to the power of 8. So 1.011 to the power of 8, I get 1.09146357 times x. Same thing, I'm going to store this in 2. And if you weren't here when we were talking about storing things in your calculator, right, you just hit the STO button and then put it in whatever button you want to store it in, right? And then to use it, you hit the recall and then hit 1 or 2 or whatever you stored it in. Because that's going to come in handy. So store in 2 in case I forgot to do it. Finally, we can find future value 3 is the present value times 1 plus I to the n. Present value is still x times 1 plus 0.011 to the power of 12. 1.011 to the power of 12. You get 1.140286196x. And same thing, I'm going to store this in 3. Looks like it's 10 to the power of 36. 1.011 to the power of 12. You might have not had your decimal.
Oh.
That would do it. Okay. So now I've stored this in 3. Okay. So now if I scroll back up here, right, I have all these future values in terms of 1 point something times x. Right? The 1 point something times x makes sense, right? Because this x has to grow to a little bit bigger than x, right? 1 point whatever x. Right? And so all of these are going to be in terms of x. So we know that x plus this one plus this one plus this one all have to total 10,000. Okay? So we'll start there. So we know that 10,000 has to equal x plus future value 1 plus future value 2 plus future value 3. 10,000 must be x plus, and I'm gonna recall 1.0447313339x plus recall 2, 1.09146357x plus 1.140286196x. I ran out of room. So then, remembering that this is 1x, right? You don't want to forget about this 1x. Right? 1x plus 1.04 plus 1.09 plus 1.14, right? Collect all your x's together, collect those like terms. And then we have, I can do 1 plus recall 1 plus recall 2 plus recall 3 equals 4.276481105x must equal $10,000. So then to solve for x, right, I'm going to divide both sides by 4.27. Yeah. Because you got to have this 1x. Right? You don't want to forget about this little guy. It's very important. Then you get it? Yeah, got it. Good. Okay. So now x must be 10,000 divided by 4.276481105. So x must be 10,000 divided by that guy, 2,338.37 pennies. So now what we're saying is that if we deposit $2,338.37 at each of these specified time points, right, at 4.4% compounded quarterly, we're going to have a total of exactly $10,000. Nice. Yeah.
Doesn't time go down, but our compounded frequency does go down? It stays 4 each time, but the time goes down by year.
Because time, right, is the length of the arrow, but the frequency, we're always compounding quarterly. Right, so every 3 months, 4 times per year. Yeah.
Oh,
yeah. So we're trying to figure out how many compoundings we have in this time frame, right? Which sometimes it makes sense that we can just kind of quickly do it in our heads, but I like to stick to the formula, right? Because if I said, okay, if you're compounding 4 times per year over 3 years, how many compoundings do we have? Right, we've got 12. But if we had something like, oh, we've got 1.3 years and we're compounding bi-weekly, then it just gets out of hand. Okay. So I like to stick with the formula regardless. But the frequency is going to stay the same as long as the interest rate is the same for all of those. That makes sense?
Like it counts per year.
Exactly. Yeah. Cool. Any other questions? All right. So, the moment you've all been waiting for, 5.5, how do you use your calculator to do these problems? 5.5. Using your calculator for compound interest problems. It only works for compound interest, right? It doesn't know simple interest. Okay. But these are what we call our time value money functions on our calculator. Which, if you've attempted assignment 2, right, then I get you to check your answers and do the work, right? So you do the work and then you check your answers, or you do the work on your calculator and then you do the work by hand, right? So we'll always be able to do it by hand or on our calculator, okay? What's nice is, right, written assignment 2, I've got it laid out so you can see which one you like better. On the test, as long as you show the work the way that I'll show you how to do it for your showing your work using your calculator, you're allowed to use your calculator, right? Unless it says do these things by hand. On test 2, you've got a choice. You can use your calculator for all of it if you want. On the final, there will be some questions where it says you have to do these by hand, right? But it's good to kind of get used to using your calculator, because it's even if you're doing it by hand, it's really good to be able to check your work. Right? Right. So these are the buttons you paid the money for. You've got your white buttons, they're even highlighted on here. You've got N, interest per year, so N is the number of compoundings. I'll make a list of all the things, right? But N, number of compoundings, interest per year is your interest rate, PB is your present value, PMT is your payment amount. We're not going to get to that till chapter 6, right? So I'll show you how to deal with that. And then you've got your future value. Right? There's also, we have to use the second function, payments per year, which is in the interest per year button, right? So you have second interest per year, takes you to the payments per year. Okay? So if you go in there, then you can scroll down to C per year, right? And I'll show mine on the board in a sec here, but I'm just kind of talking through it. Okay? And the C per year is the compoundings per year, right? So that's where you're going to put your F. Okay? Okay, so for using our calculator, we need to fill in the following buttons. And just listing them as they appear on our calculator. That way I can make sure that I don't miss any. And interest per year, present value, PMT, future value, and then moving on to the payments per year and the compoundings per year. We're N. Yeah, CY. That's okay. So N is the number of compoundings. Oops. Number of compoundings, which you'll have worked out in your timeline anyways. Right? The interest per year is the nominal interest rate as a percentage, right? So if the rate is 5%, you would just put in 5. Okay? So you don't change it to 0.05. Okay? So this is the nominal rate as a percentage. So this is another one of those times where you don't change it to a decimal, you just leave it as a percentage. PV is the present value. PMT is the payment amount. Even though you might be tempted to use it for these unknown payments, it doesn't quite work like that. We're not using until annuities, which is in chapter 6 and 7, I think. Which if you have your formula sheet, if you flip it to the back, you've got all your annuity formulas. So just looking at those will probably make you a little bit happy that the calculator can just do all those for you. Okay. Oof, gross. All right, but for now, we're not using the PMT until after test 2. FV is our future value. The payments per year, P per Y, is the payments per year. Again, we're not using until annuities. And then finally, we've got our compoundings per year. Right. Which is just where you're going to enter your F. Second interest per year. Quick note here, I'll highlight that these two, right, the payments and the compoundings per year, you have to use your second. So these are in second interest per year. Okay. You will see payments per year first, then scroll down, right, using the arrow, the down arrow, to see compoundings per year. Okay. When we're working in the second menu, right, so the payments per year and the compoundings per year, if we have to change the compoundings per year, you just change the number and then hit enter to store it. Okay. So I'll show examples, but I'll just make a note of it here while I'm talking about it. Right. To store values in payments per year or compoundings per year, we need to hit enter to store them. Just like with the days between dates, where we entered our new date and then we had to hit enter for it to solidify, right? So in general, always when you're in a second menu, you have to hit enter just to store it. I know this doesn't really make sense until we go through it, but just want to have all these notes done before we do. So what we're going to do is the value that we're going to store or solve for, sorry, we're going to use 0 temporarily, right? So what we're going to do is we're always going to just go through to show our work. We're going to show what all of these are, right? I'll go through and show you how to do that. Okay. And temporarily, the one we want to find, right? And we can solve for any one of these. We use 0 temporarily, and then just like we did with the days between dates, we go back to the one we want to compute, and then hit the CPT button, right? Compute future value, for example, and then it'll fill it in with the answer. Okay. So what we're gonna do, just for now, right? Because we're not using these guys, right? And so for PMT, you're gonna use 0. Always. And for the payments per year, you're going to use the same as the compoundings per year. Okay. So I'll just make a note here. Until we start using PMT, we will use PMT equals 0. Right. And for payments per year, we will use the same value as compoundings per year. Yeah. Another little thing that we have to get out of the way kind of is, and this is just how the calculator works, okay? The present value and the future value have to have opposite signs, meaning one has to be positive and one's going to be negative. It doesn't matter, right? But later on, what we're going to do is we're going to use the convention that money leaving our hands, right? So be it me depositing it at the bank or me paying the loan back, right? So if money's leaving my hands, I'm going to make it negative, right? And if I'm receiving money, right, getting paid, or if I'm getting a loan even, right, if money comes to me, then I'm going to make it positive. So for now, it doesn't actually matter which one we make which. Later on it will. So it's good to get in the habit of saying, okay, is it money leaving my hands? Negative. If it's money coming to me, positive. Right? So, but for this test, it's not going to matter so much, right? Later on, it will matter. So it's good to just start paying attention to these things right away. Okay. So, oops. The sign, right, positive or negative, for the future value and present value must be opposite each other. We will use the convention that money leaving our hands will be negative, right? Whether that be I deposit at the bank, right? Or if I'm paying back a loan, paying back, right? So money leaving my hands is negative. Money coming to me will be positive. Right. So that can be if I receive a loan amount, right? So if I get a loan, or if I get paid in any way. Right. Just some examples.
Would that also be considered the future value if it's accumulated to you?
Yes. As long as you're withdrawing it. Right. Okay. So I think the best way to look at this is by an example. Right. So let's do example 188. I don't actually have a picture of it, so we'll just write it out. $500 is invested at 7% interest per year, compounded semi-annually. Found it. What is the value of the investment? What is the value of the investment after 10 years? So we can do a quick little timeline just to get a grasp of all this, right? This would be a typical short answer question, so you don't need to have a timeline at all, right? I just like to do them. I like to do them. So here I've got today, and I'm investing it for 10 years. And I'm investing $500 today, and it's going to grow to some unknown future value. I'll complete this timeline and say N is time times the frequency, right? We said that R was 0.07 and F was 2, right? Semi-annually. So N must be 10 years times 2. So I've got 20 compoundings. And then somewhere kind of below here, I'm going to say I is R over F, which is 0.07 over 2, 0.035. So we know how to do this by hand, right? We're getting pretty good at these by hand, calculating the future value, right? But now we're going to do it on our calculator. So on our calculator, what we're going to do to show our work is we're going to list all the things, right? And interest per year, present value, payment amount, future value, payments per year, compoundings per year, right? It's going to be your list. So we've got N, interest per year. And I just, like I said, I always just do it in the order that they appear on my calculator so I don't miss any. Present value, payment amount, future value, and then payments per year and compoundings per year. Yeah. I'll just make a note here because I'm about to see video around 1 hour. right? If you just want to skip forward to the calculator bit, right? Because I'm about to flip the screen and show on the camera. So just making a quick note. Okay. But first, what we're going to do is we're going to go through and we're going to fill all these slots with all the information that we're going to enter. And that's how we're going to show our work if we're using our calculator.
Do you want us to use that asterisk to?
I do. Thank you. So what we're going to do, right, is we're going to say N is 20. The interest per year is 7, right? I still want you to, even if you're using your calculator, I still want you to calculate the periodic interest rate to show me that you know that you would have to do it, right? Using your calculator, you don't actually have to, right? But for now, right, I just want you to keep calculating the periodic interest rate. But here, the interest per year is just 7, right? Mm-hmm. The present value is 500, right? And presumably, I'm investing this 500, right? So it's leaving my hands, going to the bank. So let's make it negative. I'm investing this money, right? Making it negative. So then my future value that I calculate is going to be positive, right? But even if you're calculating the other way around, right, and you get a negative value, that's not negative money. It's just telling you that this is money that you have to pay. The payment amount, like we said, we're just going to use 0 for now, right? And then the future value is the one that we want to solve for. So I want you to put a little star there. Sure. Okay. So solving for the future value, so we just put a little star there, and then we'll fill it in once we have our answer. We know our compounding frequency is 2, right? So we're going to use 2 as our compoundings per year. And for now, yeah, sorry. Yeah, we would have if we're doing it by hand, but the calculator still needs to know for whatever reason.
But if your number of compounds is already in the calculator under N as 20, doesn't that already account for a semi-annual frequency?
You would think.
Yes, I just did
Yeah.
that, and the difference is only like $40 between the two final answers. I'm wondering what that actually does.
It's probably
The
because it
compoundings
knows
per
that
year.
There's a compounding in there. It probably just doesn't know the exact number.
Yeah, I don't actually know. I think like
There's a lot of ways to get.
we could probably look at the programming of the functions and get to the bottom of it. But all I know is you have to enter it because it is giving you a different answer.
Yeah.
Yeah.
Yeah, slightly different. But I remember in my accounting 2 course, we never got the compounding for the just accounted for that
In the end.
number
Yeah.
of payments or number of compounding, and we always got the right answer.
Okay. Yeah.
Is that even necessary?
For us, yes. Yeah, because you are going to get a slightly different answer, right? So, yeah, that's the end goal, right? Yeah. So for us, yeah, we're going to have to use it. But you're right. I agree that it should only need what we need to do it by hand. But yeah. Oh, maybe it's the interest per year because we're not giving it the periodic interest rate. We're just giving it the raw rate. So that's maybe what's going on. It needs to calculate the periodic interest rate internally. Is my best guess.
Y is also 2? Like,
As a rule for now, because we don't have any payments per year, we have to use the same value here and here.
so when we enter it in our calculator, we're not gonna just scroll past PY, we're gonna enter.
We're gonna
2 in that
enter
as
2
well.
in that as well, yeah. So that's why, that's why you wanna go through and make this list before you actually plug it into your calculator, right? But now, let's see if I can. Instructions on back there. Okay. Whoop. Whoa. Okay. Let's see here. Let's see if I can even zoom in a little bit. How's that? Can you guys see the calculator? Yeah. Yeah, okay, so what you have to do is you have to put in the number and then hit the button you want to store it in, right? And so, yeah, so let's start with n equals 20, right? So what you're gonna do is you're gonna have 20 on your screen and then hit the n button, okay? And so as long as you see n equals 20 up here, then that's good. You just have to trust that it's there, because if you were to have a different value on the screen and then go back to check that n is still 20, it's going to change your n, right? So we just have to, okay, if it says n equals 20, we just trust that it's in there, okay?
There's no way to double check.
There's no way to double check.
We still have to hit enter.
No. So what's nice with these white buttons is you don't have to hit enter, right? It's already logged it as n equals 20. Okay? So then we can go on and we just say, okay, now 7 is our interest per year. See, it's 7, the I per Y. And then now it just knows that that's your interest rate. Okay? Now moving on, so 500 is your present value. So these white buttons, they're pretty quick to, we just fill them in. Yeah. Oh, thank you. Thank you, thank you. Negative present value. Right, so then I can just restore it if I muck up like that. Thank you. Okay, so then we've got negative 500 in our present value, and we're storing 0 into our PMT. Okay. What's nice is that now that we know that PMT is 0, it's always going to be 0. So none of these values change until we go in and overwrite them, right? So if you have the same interest rate, if you have the same present value, if you have the same kind of main values, right? And the only thing that's changing is n, for example, then all you would have to do is change n and go back and compute your future value, for example, right? So now our PMT is 0, so we can just forget about PMT. You're still going to list it in your list for completeness. Right? And so remember, we're solving for the future value. So we're just going to put 0 in there for now as a placeholder. Okay? So 0 is our future value, and then we're going to come back and compute it. Okay? So now you're going to go into the second menu. Second, interest per year, right? Because that's where you have your P per Y up top. It's kind of laggy here. Okay, so I don't know what you have as your P per Y by default, right? 1, okay. So if I wanted to change it to 1 to be like you guys, right, I would put 1 But remember in the days between dates, we had to hit enter, and the way we could make sure that it was storing it was with the equal sign appearing, right? So the same thing applies here. So you want to hit enter to store it. And now it'll show payments per year equals 1, okay? What we want though is 2, right? So I'm going to change it to 2. And remember, as soon as I change the number there, the equal sign goes away. So I have to hit enter. Okay. And what's nice is that if you scroll down, so hit the down button to your compoundings per year, right? If you've changed your payments per year, it'll just change your compoundings per year for you. Right? So you can always just scroll down and check to make sure that it's changed, right? Because even if you had 1 initially for your payments per year, once you scroll down to your compoundings per year, did you get 2? You changed it to 2? Nice, right? So that's nice. So it's saying, okay, if you know your payments per year, right, then I'm just going to change the compoundings to be the same thing. And if you want to change it later, you can. Right? For us, no, we want them to be the same, so we're just going to leave it. Okay. All right. So to get out of the second menu, right, you're going to hit second quit, right, which is just the compute button quit. Okay. So now we want to go back. Our whole goal is to find the future value, right? So we're just going to hit compute future value, CPT. Oh my God. Future value. Right. So we have a future value of $994.89. Done. Good. So you could easily go through and check this work, right? But you should get the exact same answer, right? Cool. Nice. Yeah, so pretty fun. Yeah. So I'm just going to flip back to my notes here. So we said we have a future value of $994.89. I'll put all my decimals. 89,44317. May as well show off, put a little box around it. Okay. So here, I'll just make a note of how we entered these, right? So what you're going to do, you have some value that you want to fill into, I call it a slot, right? And interest per year, future value, present value, all those fun things, right? And so on your screen, enter the value you want to fill a slot with. To fill a slot with. Then press the button you want to fill it into. I don't know. That's why I made a video. It's hard to articulate. Okay. So then press the button you want to fill it into. Great. Cool. Any questions about that? No. So
for any of them, like if you entered all of that info and then like hit like trying to compute the present values.
does. Let's see. Let's do another example. I'll move down. Hard to write on an angle here. I was such a trooper in the beginning when I was writing on an angle. But now, too far into the term. No, too deep into the term. Wow.
There's some way compound.
Yeah. Why not simple interest? Because even if we change the compoundings per year to 1, right, which is kind of maxed out, simple interest never compounds, right, until the end. So I suspect that it might work if it's less than a year. Maybe. I've never tried. Try it. Oh, bummer. Yeah, it doesn't do simple interest. But it does do annuities, so phew. Compound interest and upward, it'll do. Okay. So, let's do example 189. And we're just going to do it on our calculator. Oops. Example 189, determine the number of compounding periods that it takes for an investment of $10,000 to reach $12,000 if money earns a rate of interest of 5% per year compounded monthly, right? Simple problem that we'll start with, right? Get used to our calculator, classic kind of short answer problem, right? And that's what's nice. So for the short answer on the test, you don't have to show any work unless you want part marks, right? You just, if you are confident in your answer, you just have to put the answer. And then, so you could do it on your calculator quickly, right? Jot down the answer, move on. Okay. For part marks, of course, you have to show your work. But if you're feeling lucky, you don't have to show any work at all. Okay. So I'm going to draw a timeline. I don't have to. We don't have to, but it's good. So I want to know how long, right? So from today to some unknown date, is it going to take for $10,000 to grow to $12,000? And I'll just jot down the rate is 0.05 and the frequency is compounded monthly, so 12. Exactly. So n is unknown, right? We don't know n. And that's what we're trying to find. I'll even push us one step further and ask you, right, how long is it going to take, right? Not just how many compounding periods. We don't really talk in compounding periods, right? But that's the same as what we were doing last day, right? We have to find n to find t. And so, and I'll calculate I is r over f, which is 0.05 over 12, 0.05 over 12. 0.00416 repeating. I'm going to be using my calculator, so I don't actually need it, but I want to see it calculated, even if you're not using it. Okay. So on our calculator, I'm going to go through, I'm going to write out my list first, right? N equals interest per year equals present value equals payment equals future value payments per year. Oops. Compoundings per year. N is the one I want to solve for, right? So I'll just put a little star there. So we'll enter 0 temporarily, come back, compute it. The interest per year we said was what, 5%? So we'll have 5. The present value, let's make it negative again, right? As long as they're opposite for now, it doesn't matter, right? But we're investing this money, so let's assume that we're investing this, right? So we've got negative 10,000. The payment is 0. The payment amount is 0, right? So we're not using it, so we just use 0. And the future value is positive 12,000. The compounding frequency is 12, right? So we've got 12 compoundings per year. And so we're just going to have 12 payments per year entered in our calculator. Okay. So let's get to work. Let's fill these slots. So we're going to enter 0 for n for now, right? And then we've got 5 as our interest per year, 10,000. I won't forget my negative this time for the present value, 0 for the payment, even though payment would have been 0, right? Until we change it, I just like to do it all the time. Right? Then 12,000 as our future value. And so now we go into our second menu, payments per year, and we're going to change it to 12, right? But we have to hit enter to store it. And then scroll down. The compoundings per year should be saved as 12 already, right? As soon as we change our payments per year, the compoundings per year change as well. So now we can go second quit and then compute n. So I get 43.84827,123. I'll put a box around it to show off my answer. Right. Again, right, to finish off this question, well, I'll ask how long is it going to take, right? But the number of compoundings that we would need would be 44 compoundings, right? Because we can't have a fraction of a compounding 43, we wouldn't have quite 12,000, right? If we only went to 43 compoundings, we'd end up somewhere around here, right? So we have to go to 44, which means we're going to have slightly more than 12,000, but that's better than not having quite 12,000, right? So we would need n equals to 44 compoundings. What if I asked how long will this take? Right, so find t. And, right, is t times the frequency. We just said that n is 44. T we're trying to solve for, and f is 12. So t is 44 over 12. So time must be 3.67 years, right? I'll do the 6 repeating, or 3.67 years. Cool. Or 44/12 of a year. It's fine too. But that doesn't really mean anything to us, right? So I convert it to a decimal. Okay. Any questions about that one? Cool. So the calculator, right, you're going to use it for those TVM questions on your assignment, right? But now you'll be able to check your work, do the work on your calculator and by hand, right? And you'll see that they kind of go hand in hand. Okay. So we're going to talk briefly about 5.6 and 5.7. Okay. 5.6 is on changing interest rates. So remember, we did this in simple interest as well, right? Where we have some rate, so 5% for the first 3 months, and then it goes to 6% for the next 3 months, and then it goes to 7% for the next time, right? Next 3 months, let's say, right? So we did one of those. We could have the same scenario with compound interest, right? So we need to know how to deal with that. So changing interest rates. Okay. On your formula sheet, you have the future value is the present value times 1 plus I1 to the power of N1, right? The first interest rate period, right, is going to have some number of compoundings and some periodic interest rate times 1 plus I2 to the power of N2, right? The second interest rate, right? So when it changes, it's going to be available for some number of compoundings at some periodic interest rate, and so on and so forth to 1 plus n sub k to the, I sub k. Because we're in math and we like that.
Sure.
So instead
Love
of
it.
just K.
It's allowing for k interest rate changes forever. We could use any, usually we like to use the middle of the alphabet. K, M, N's already taken, so we can't use that, but L is common. For some reason, we like to use those as like general subscripts. Why we didn't use the same one, I have no idea. You'll have to ask Joe. Probably. That's always the case. It's like, oh, that was taken, right? So where, for example, I subscript 1, right, like we said, is the periodic interest rate for the first interest rate, is the periodic interest rate for rate 1. And n sub 1 is the number of compoundings at rate 1. Number of compoundings for rate 1. Right. Same for I2, I3. We'll probably only have 3 or so rate changes. Right. K is a little excessive. So as an example, let's have a look at example 190. Okay, so CIBC changes their rate from 4% compounded annually from the start of 2000 to the start of 2002. For the next 2 years, their rate switched to 4.75% compounded quarterly, right? So it's allowing for different compoundings as well. The following year, the rate was 3.5% compounded semi-annually. You invested $1,000 at the start of 2000. How much do you have in the bank account after 5 years? Right, so what's your future value after all these rate changes? And I think we understand when we deposit money, right, the rate is going to change, right? We can't usually lock in a rate, right? The rate's gonna change. So first, let's map this out. Okay. So we know that we're gonna be looking at 5 years. Thank you. Thank you. Oh yeah, grab your practice test. Do you guys have written assignment 2? No? 2 and 1? There you go. Great. So we've got today and 5 years from now. And it looks like all these changes are being changed even every 2 years, right? So we've got 1 year, 2 years, 3 years, 4 years, 5 years, just to make it nicer to look at. You don't have to have the 1 year mark. Oh. 3 years and 4 years. So I've invested $1,000 today, and it's gonna sit there for 2 years, right, to 2002. Right, this is gonna be 2002. And then there's gonna be a rate change in 2004, and then we're ending at 2005. So for this first interest rate, right, we've got a rate of 4% compounded annually. So the frequency is 1. And so for this first one, n is time times the frequency. So we've got time, and I'll do n subscript 1. I left myself a little bit of room. Uh-oh. Is the time, which is 2 years, times the frequency, which is 1. So I've got n1 is 2. I'm going to calculate I1. I1 is R over F, which is 0.04 over 1, which is just 0.04. Right. So then it says for the next 2 years, the rate switched. Okay, so for the next 2 years, the rate switched to 4.7%, or 4.75, sorry. The rate is 0.0475, compounded quarterly. So now F is 4. I'll write down N2 is going to be time times the frequency. Again, the time is 2 years times the frequency, which is 4. So I've got 8 compoundings there. I2 is going to be R over F, 0.0475 over 4. 0.0475 divided by 4, I get 0.011875. And then finally, for this last year, the rate is 3.5% compounded semi-annually. 0.035 compounded semi-annually, so the frequency is 2. I3 is R over F, which is 0.035 over 2. 0.035 over 2 is 0.0175. So N3 is the time, which is 1 year times 2. Kind of cutting to the chase there. And then finally, I'm going to end up at my future value. And we want to find our future value. future value is the present value times 1 plus, where did I have it? I1 to the power of n1, oops, times 1 plus I2 to the power of n2. Oh, not plus. Times 1 plus I3 to the power of n3. Right. Technically,
Do we have to do the timeline?
you don't have to do the timeline. The timeline was just to kind of show you what was happening, right? And it's a way for me to jot down all this information, right, and kind of map it out. But unless I make you do this for a timeline question, which I don't think I wouldn't, then you don't have to do a timeline, right? As long as you go straight to the formula, that's fine by me, right? You'd still have to calculate I1 and N1, I2 and N2, I3 and N3, but you can just do those separately. So the future value is our present value, which is $1,000 times 1 plus I1, which is 0.04 to the power of N1, which was 2, times 1 plus I2, which is 0.011875 to the power of N2, which is 8, times 1 plus 0.0175 to the power of N3, which is 2. So I get 1,000 times 1.04 to the power of 2 times 1.0816. I'll make a note here that I'm going to store this in 1. And then I'm going to do 1.011875 to the power of 8 is 1.09904368. I'll store this in 2. 1.0175 to the power of 2 is 1.03530625. Of course, I'll store this in 3. So now if I just do 1,000 times recall 1 times recall 2 times recall 3 equals 1,230.69502. Did you get equals? $1,230.695 makes 70. Phew. I'd say this is more of a short answer question than any sort of long answer question, right? Just something we need to know how to deal with, right? Both in the simple interest case and in the compound interest case. Okay. So same with 5.7, which is about continuously compounded interest, okay? Which to me is kind of like a mind bender, because it's not compounded every day. It's not compounded every hour even every minute wouldn't be enough. It's continuously compounded, and that's kind of hard to wrap our head around, right? But if you look at your formula sheet, the very last formula sheet has, or the very last formula on your formula sheet has the formula for dealing with continuously compounded rates, okay? So 5.7 is on continuously compounded investments. Which is kind of a cool idea, right? Continuous compounding, right? It's just always compounding. We use the future value is the present value times e to the power of RT. And it's that E that's going to help us deal with the continuous compounding. And yeah, so E to the power of whatever is on your calculator. So I'll show you how. Okay. Where R is still the nominal interest rate. And T is our old faithful time in years.
It's terrible.
So, example 192, to have a look at continuous compounding. Mhm. 13 years ago, you borrowed $7,500. So you borrowed this money, at a rate of 2.5% compounded continuously. This cannot end well for us. What would the equivalent annually compounded rate at which you borrowed this money be? What would be wording, whatever. So first thing we're going to do is we're going to figure out what amount, so what future value is this continuously compounded rate going to give us, right, from 13 years ago. Okay. And then we're going to use that future value to figure out what the equivalent annually compounded rate would be. Right. So let's just jot it out. Jot it out. Today, 13 years ago, you borrowed $7,500. So you've got a future value that we have to solve for. Right. R is 0.025 and F is continuous. That's right. Well, I guess we'll see. It is sounding pretty bad. So now we're going to use our future value, because we can't calculate n because we're continuously compounding. Right? Technically, n might be infinity. Continuously compounded. But 13 years ago, it's not looking good. So maybe I'll sneak that on the timeline here. T is 13. So we use our continuously compounded formula, which is PV times e to the RT. So our present value, 7,500. And then we have e to the power of 0.025 times t, which is 13. All right, so I'm going to simplify that power first. So we have 7,500 times e to the power of 0.025 times 13 is 0.325. Okay. On your calculator, on screen, you're going to have 0.325, and then you're going to hit second ln, right, for e to the x, right, for the e to the x function. So you have 0.325 on your screen, and then second ln So I get that this equals 1.3840646,840. Right, so e to the power of 0.325 is 1.384 whatever. So now I can take that times 7,500. Show my work here, 1.384030646 times 7,500. I would have to pay back $10,380, 0.22984, which is $10,380.23, which, considering it was 13 years, isn't actually as bad as you might have thought. It's not a good idea, but so next day we'll just finish this off because we don't have time, but we'll figure out what would the annually compounded rate that's equivalent to that be.
Is the stuff that we learn tomorrow or on Thursday on our exam on Thursday?
No, because we're just going to finish this up. Well, I mean, technically, yes. We're going to finish this off on Thursday and then do the practice test.
Oh, we're gonna do the practice testing class?
Yeah. Together.
So we gotta do it for homework.
You gotta do it.